No, you're not listening to a fax. You're listening to me, and I'm going to teach you guys lesson 8.2 on linear equations and two variables and using intercepts. All right, now from the last lesson, we described relations and functions as sets of ordered pairs. In fact, that's how we defined a relation, as any set of ordered pairs. We also set up a table, we did a mapping diagram, and we showed it with a graph. Now what we're going to do is we're going to consider what we can do with relations and functions if we think of them as an equation in two variables. And here's an example right here. X minus 3y equals negative 1. It has the two variables x and y. Those are the two variables that we use most of the time. That kind of matches up with the x-axis and the y-axis on the Cartesian plane, or the coordinate axes. All right, so let's start with the definition of what a solution to an equation like this must look like. Because the equations that we have dealt with up to this point have only had one variable. They either had an x or a y or a w or an a or something like that. Never have we come across one with two variables quite like this before. So a solution of an equation in x and y is any ordered pair, x, y, that produces a true statement when the values of x and y are substituted into the equation. Well, we did this when we were solving equations in one variable. We would get our answer, we would substitute it back in for the variable, and we would see if we would get a true statement or not. If we got a true statement, we knew it was a valid answer. Well, that's kind of what we're doing here, except now we have twice as much fun because we have two variables to consider. So let's look at this example right here. It's the same examples above. Tell whether the ordered pair is a solution of x minus 3y equals negative 1. And I have three different answers to choose from. Okay? I have 4, 2, 2, 1, and negative 1, 0. So what we're going to do is we're going to substitute this in for the x and this in for the y. This is the x coordinate, this is the y coordinate. So into x minus 3y equals negative 1, I'm going to plug a 4 in there, I'm going to plug a 2 in there. So that would give me 4 minus 3 times 2, 3y means 3 times 2 equals negative 1. I multiply. Before I subtract, 4 minus 6 equals negative 1. 4 minus 6 is negative 2. Now that's not true. So is this an answer? No. Now I'll try this all over again, but with this ordered pair. So x minus 3y equals negative 1. I'm going to plug this in for the x. I'm going to plug this in for the y right there. So I get 2 minus 3 times 1 equals negative 1. Well, again, I multiply. That's 3. And 2 minus 3 is negative 1. So that one is true. Negative 1 does equal negative 1. So my answer here is yes. Now I'll try for this third example. Negative 1 in for the x, 0 in for the y. So I'll write it down again here. And I'm going to plug the negative 1 in there and the 0 right in there. And I get negative 1 minus 3 times 0 equals negative 1. Of course, 3 times 0 is 0. And negative 1 minus 0 is negative 1. So again, I get a true statement. Now, when we had equations in one variable, we only had one answer that was true. And as you can see here, with this one example, I've shown you two answers to this equation that has two variables. Now, can there be more than two answers? Is 2 the maximum? Well, let's wait and see. Let's consider what the graph of an equation in two variables looks like, and then maybe we'll have an idea of how many solutions these types of equations might have. Well, the graph is the set of all points in the coordinate plane that represents the solutions of an equation. And the most popular type of an equation that you'll see in this course is what's called a linear equation. Now, I've kind of left a blank there. It says a linear equation is an equation whose graph is a, and then it says there's a blank here. So I have actually two linear equations that are written out, and we're going to see what we're going to have to fill that blank in. Now, we have an equation. We don't have the solutions. We have to come up with the solutions. So that's where you can create a table of values to help you with that. And so what I'm going to do is make what we call a t-chart. The t-chart is the x and the y. For the x variable and the y variable, and that's going to give us ordered pairs. I'm going to independently choose some values for x. So I'm going to make them very easy values to plug in. I'm going to plug in negative 2 and negative 1 and 0 and 1 and 2. Bring this down just a little bit. So if I substitute negative 2 in for x, I want to determine what y has to be to make that true. So if I plug negative 2 in here, the opposite of negative 2 is 2, plus 2 is 4. Y would have to equal 4. If I plug negative 1 in, the opposite of negative 1 is positive 1. Plus 2 is 3. If I plug 0 in, the opposite of 0 is 0, plus 2 is 2. If I plug 1 in, the opposite of 1 is negative 1, plus 2 is 1. And if I plug 2 in, the opposite of 2 is negative 2, plus 2 is 0. So it looks like I have a pattern here. So I'm going to graph these solutions as ordered pairs. Ordered pairs like this. We know how to graph ordered pairs. We've been doing that for a while. Negative 2, positive 4. So from the origin, 2 to the left, and then up 4 units. And you try to be careful with this, and you should use graph paper. Negative 1, 3. 1 to the left, up 3 units. 0, 2. 0, right or left, up 2 units. 1, 1. 1 to the right, up 1 unit. And 2, 0. That's 2 to the right, not up or down any units. Now, even though my graph is a little crooked here, hopefully you can see that these 5 points, all representing solutions to this equation, are on the same line. They're collinear. Now, I only picked 5 x values, and I have 5 solutions. Think about it. If I keep picking x values and plugging them in, I'm going to get more solutions. I'm going to have infinitely many solutions. And because of that, I have infinitely many points. And these 5 points give me a pattern that shows me that my graph, if I can draw this with the dart, nope, is going to be a line that contains those points. In fact, see linear right here, the first 4 letters? A linear equation is the equation whose graph is a line. Okay, that's the name. So this type of an equation graphs a line. Now, we know with the lines, there's infinitely many points. We can't graph them all. We need just a few, because a few will be enough. We know that the straightest, or the shortest distance between 2 points is a straight line. We need at least 2 points, and I'm going to suggest 3. So when I make my table for this problem, I'm not going to plug in 5 values of x. I'm only going to plug in 3 values of x. Now I notice here that whatever I plug in, I have to take half of it. And so I'm not going to plug in an odd number. I get to independently choose the values I want for x here. So I'm going to plug in some even numbers. I'm going to plug in negative 2, 0, and positive 2. I can pick those values. You can pick bigger numbers, but you might have to make a bigger graph. So if I substitute negative 2 in for x, 1/2 of negative 2 is negative 1. Minus 1 is negative 2. If I substitute 0 in for x, 1/2 of 0 is 0, minus 1 is negative 1. If I plug 2 in, 1/2 of 2 is 1, 1 minus 1 is 0. So I have negative 2, that's down here. Negative 1, 0, that's right here, and 2, 0. Oh, excuse me. Well, mark that wrong. Let's try that all over again. 0, negative 1, not negative 1, 0. 0, negative 1 is right here. 0 right or left, and then down 1 unit. Now 2, 0. That's 2 to the right, 0 up or down. And again, even though my graph is a little crooked looking, you can hopefully see that those 3 points are indeed collinear. So I would grab a straight edge. I'm going to freehand it because I don't have a straight edge to use. And I'm going to graph that line. Now notice here that this line goes up and to the left, this line goes up and to the right. So there are all sorts of different kinds of lines that we might end up when we're graphing. Okay, there are 2 special equations. Now notice I wrote in 2 variables, but that's almost a contradiction because look at my equations here. You have the equation x equals a, where a is a number, x is your variable. That only has 1 variable. But technically, when we look at this type of an equation and we're dealing with 2 variables, it is also a special type of line. It's a vertical line. Now remember, vertical goes straight up and down. It's a vertical line that goes through a 0. This type of line, y equals b, now again, b is a number, y is your variable. It only has 1 variable, but again, we're thinking about this in terms of 2. So when we're looking at an equation that looks like this, we get another line. This time we get a horizontal line that goes through 0b. Now these are 2 very special cases, and they're the easiest ones to graph, but students mess up on this because they think something is really wrong when they only see 1 variable. If I see graph and I have coordinate planes here and there's only one variable, I know I'm going to get a vertical or horizontal. If it's x equals a number, it's vertical. If it's y equals a number, it's horizontal. Well, this one is vertical. It's x equals 1. That means it goes to the point 1, 0, which is right here. I have to draw a vertical line, and I'm a little unsteady, so kind of bear with me there. There's a vertical line that goes through that. Now, what's really nice, I didn't need a table. I know what vertical looks like. I didn't need at least 2 points. I needed just the one. This point here where it crosses the x-axis, which, by the way, is called this point right here where it crosses the x-axis. That's called the x-intercept. It intercepts the x-axis right there at the 1. And remember, this is the x-axis, this is the y. This is the x-axis here, this is the y. Now in this equation, y equals -2, there's only the variable y, so I know that's a horizontal line. And it's a horizontal line that's going to go through the point 0, -2, which is down here, 0, -2. Horizontal goes across, like the horizon. And I have my graph. And again, I don't need a bunch of points here. I only need the one point right there so that then I draw my horizontal line through it. Now this is where it crosses the y-axis. This is called the y-intercept. This one was called the x-intercept where it crosses the x. The other one was called the y-intercept. Now, a linear function, okay? We're going to talk about that. Now look at these two lines that we have here. This line right here would fail the vertical line test because if I drew from the last lesson, if I drew a vertical line right here, right over this, it would cross it at every point. So this type of a line is not a function. This type is, the ones that I graphed from before were okay. They would pass the vertical line test, but not a vertical line. So a linear function, remember a function has to pass the vertical line test. A linear function is a function whose graph is a non-vertical line. It'd be any other type of line except a vertical line. And when we write linear functions, we want to put them in what's called function form. Function form is when the equation is solved for y, when the y is all by itself. Kind of like this. This is technically function form. The y is solved all by itself on one side. We'll do a couple more examples. Okay, let's write these two equations here in function form. That means we have to solve for y. So we use the same steps that we did when we solved equations in previous units by isolating the variable, in this case the variable y. It's just that we have two variables, so we have to kind of keep track of that second variable. To get the variable y all by itself, I have to get rid of the 3 that's times it. I have to get rid of the x that's being added to it. I'm going to start off by subtracting x from both sides. Now if I do that, I get 3y equals, now I can't actually subtract the 3 and x because they're not like terms, so I'll write 3 minus x. And then to get rid of the 3 that's times the y, I'm going to divide both sides by 3. Now in this case, because there's 2 terms on the right side, I'm going to divide all terms, every one on both sides, all by themselves. So I'm going to do this. I'm going to divide that by 3, that by 3, and that by 3. And I have y equals 3 divided by 3 is 1, minus x over 3, and there is my function form. Now we'll do some more with that later on in a later lesson, but for right now that would be good enough. Over here, I'm going to subtract 2x from both sides because I want to undo the stuff around my variable. I'm going to get rid of all this stuff that's around my y. I'll start by getting rid of the 2x. The 2x minus 2x, that's 0, and I get a minus y, which is the opposite of y. Over here, 3 minus 2x, not much I can do with that. I'll just write 3 minus 2x. Now, because of the opposite sign, which is like a negative 1 in front of the y, I've got one extra step. I have to divide by negative 1. And I get y is equal to 3 divided by negative 1 is 3, minus 2x divided by negative 1. That would be like a negative divided by negative. That would be plus 2x. And there is my function form. Function form is nice because when you're creating a table of values, it's easier to substitute in your x values that you've independently chosen to find the y values that depend on, of course, what your x is. All right, next, an oblique line. Horizontal lines, vertical lines are not considered oblique. An oblique line is one that's more like the example that I have graphed here. It's non-vertical, it's non-horizontal. It's typically slanted and goes up and to the right or it goes up and to the left. But all oblique lines will cross both the x and the y-axis. You can see the example here. It crosses the x-axis here, it crosses the y-axis here. Remember, I called these intercepts. The x-intercept is where it crosses the x-axis. This is your x-axis, remember? This is your y-axis. The y-intercept is where it crosses my y-axis. Do you see where my x-axis? Right here. That's at negative 2, 0. That's my x-intercept. And my y-axis, that's at the point 0, 1. That's my y-intercept. In fact, to find intercepts of a line, if they give you the equation and you want to graph, you need 2 points. The x and the y-intercepts will serve that purpose. To find the x-intercept, we'll plug y in, 0 in for y, and to find the y-intercept, we'll plug 0 in for x. I'll show you an example of that here in just a second. But I'm going to graph a line where I give you the x and the y-intercepts. Now, first off, a lot of times you will see the x-intercept not written as an ordered pair. They'll just give the 2. Or the y-intercept, they'll just give the negative 3, as in this example is showing. But the intercepts are ordered pairs. They're points. So they have to write them as ordered pairs. If you see it just given as a 2, you have to remember that represents 2, 0. If you see the y-intercept given just as negative 3, you have to remember that's 0, negative 3. So if I was going to graph the line that has those intercepts, I'm going to put it right down here. I'm going to graph 2, 0. That's right here. And I'm going to graph 0, negative 3. That's down here. And as you can see, I have a line that goes up and to the right. It's an oblique line, and it has those intercepts. Okay, when the equation of a line is in standard form, and this is standard form, that shows that the variables are on the same side, the x and the y. There's a little bit more to it, but we'll study that later on. But when the variables are on the same side of the equation, the x and the y, the a, b, and c are representing numbers, we usually use the intercepts, the x and the y intercepts, to graph. Now, I'm going to show you 3 examples here. 2 of which are already in standard form. A and B are in standard form. The last one isn't, but I'll show you what to do. Now remember, I wrote this down previously. To find the x-intercept, you set y equal to 0. To find the y-intercept, you set x equal to 0. So if I want to find the intercepts and then graph, I'm going to find the x-intercept. I'm going to find the y-intercept. The x-intercept is when the y is 0. The y-intercept is when the x is 0. When the y is 0, if I put a 0 in here, 2 times 0, that just all disappears. And let's see if I can show this to you here. If I just kind of cover it up, what's going to disappear? Right? You see I'm going to get x equals negative 2. That's my x-intercept, negative 2, 0. Now to find the y-intercept, if I plug 0 in for the x, so this will just disappear. Now, the negative doesn't disappear. That minus sign is like a negative 2y equals negative 2. Now, I don't have very much space, but if I was to divide both sides by negative 2 here, do you see I'm going to get a positive 1? And that's my y-intercept. So over here, negative 2, 0, and 0, 1. And those 2 points determine my line. It's a little sloppy, but I think if you use a straight edge, you'll do much better. Over here, to find my x-intercept and my y-intercept, just abbreviating, I'm going to plug 0 in for y for the x-intercept, 0 in for x for the y-intercept. If I plug 0 in for y right here, all that's going to become 0. Do you see I'm going to get 4x equals 12? And if I divide both sides by 4, I'll get x equals 3. Here, if I plug 0 in for the x to find the y-intercept, then 4 times 0, that just all becomes 0, and I get a minus 3y equals 12. Now, if I divide both sides by negative 3, I'm going to get a negative 4. So my x-intercept is 3, 0. My y-intercept is 0, negative 4. Here's 3, 0. And here's 0 way down here at negative 4. And it's a little sloppy, but hopefully you can follow it. 1 to go. Now, it was very convenient to find the x and the y-intercepts in standard form. This one is not in standard form. This is in function form. The y is all by itself, so I'll have to be a little more careful to find the x-intercept and to find the y-intercept. Well, out of the 2, you'll find when it's in function form, it's very simple to find the y-intercept. Remember, that's when the x is 0. I'm going to do the y-intercept first. I'm going to plug 0 in for x. Well, if that's 0, negative 2 times 0 is 0. All that just disappears. You see the y is already by itself? Y equals negative 1. So that was simple. Now, it's a little trickier to find the x-intercept when it's in function form. I'm going to plug a 0 in for y. Now, I don't have a lot of space, so I'll put it right up here. 0 in for y gives me 0 equals negative 2x minus 1. Now, I'm going to solve it like I did in my previous units of work. I'm going to add 1 to both sides. That's going to cancel out. I get 1 equals negative 2x. I'm going to divide both sides by negative 2. And I get x equals 1 divided by negative 2, or negative 1/2. Now you say, well, how do I graph negative? How do I do a fraction? Well, you have to approximate it. Negative 1/2 is halfway between 0 and negative 1, so it would be about here. And then 0, negative 1 would be right here, and I get a line that looks something like this. Now we're going to do some more graphing, and it's very important that we learn how to graph. We can use a table, especially when it's in function form, and we can use the x and y intercepts, especially when it's in standard form. But you'll get better with this with practice, practice, practice.